Thanks, Alan. Thanks everyone for being here. My name is Ryan Dempsey, and today I'll be going through the research that I did as part of the BIM Masters in TU Dublin. I just recently finished in May. So my research is in the area of BIM technologies, global warming potential of building materials. So the research question is, can BIM technologies calculate and visualise the global warming potential of building materials? And the research purpose is to investigate if the application of BIM tools can be leveraged to automate GWP to support decision making in meeting the REI climate challenge and contribute to decarbonisation of the built environment. Four objectives were proposed. So the first is to critically review the synergy of BIM and life cycle analysis (LCA) in the construction sector, to hypothesise a solution with the capacity to incentivise stakeholders to decarbonise the built environment, to progress the hypothesis from theory to application using rigorous testing, and to analyse and present findings of the application for a potential implementation in the built environment. So from the objective one, literally reviewed some of the key findings for BIM and LCA synergy. So the first is it supports decision making in the early stage of design, a reduction of errors and inconsistencies in LCA results through the synergy of BIM and LCA, an improvement of global warming potential values by combining LCA databases with the level of information needed, material libraries for quickly reviewing and visualising GWP impacts. It may facilitate environmentally friendly decisions to occur. However, due to the task of manually inputting LCA data into BIM objects, real-time footprint analysis is not achievable without additional tools. So this is where I kind of started to narrow the focus and look at automation and kind of looked at where Revit and Dynamo could be used. So through that, some findings: reduction of effort through Revit and Dynamo to access GWP totals and connect material databases, and reduction of human error through automated material mapping for LCA using BIM software. And then also last year there was an introduction of ISO 22057, which was to standardise digitalisation of EPDs, providing data templates for the use of EPDs for construction products and BIM. So taking the literature review, that kind of set the building blocks for the research, and allowed me to develop a conceptual framework. And also see Simon McGuinness in the audience, through conversation with him, we were able to develop the hypothesis for the research. So because this is a problem solving issue that I was looking at, for the study, for the methodology, I looked at design science research. So this is a problem solving paradigm that seeks to enhance human knowledge via innovative solutions to real world problems. So approaching this for joining existing processes, so BIM with building material databases to automate GWP values, the innovative solution to tackle the decarbonisation of the built environment, which is a real world problem, was the reason for choosing this methodology. So the two theories that came out of this: so the first would be the proposed tool / workflow will have the potential to deliver real-time life cycle global warming potential calculation that will incentivise better decision making and decarbonising the construction sector. And the second is the model will be used as a verification tool to record and monitor the GWP totals of a building. For the research testing, it was organised in key stages. So the first was the preparation of data sources based to be used to study the creation of a material library, essentially a green template of materials, and shared parameters based on GWP data and based on standards EN 15804 and calculation on EN 15978. The designing and modelling an example to be utilised for research and testing experimentation for the study, and the creation of visual program script to map EPD data to build materials inside the model. And lastly, creation of additional program scripts to visualise GWP data of the model and compare thresholds. So the first stage was preparation, just gathering what data sources would be used. And in this case, the benchmark targets were from the REI climate challenge, which sets out two specific targets for 2025 and 2030 for dwellings, offices and schools. The standards, as I mentioned in the previous slide, is EPDs based on EN 15804 and calculation based on EN 15978. The material databases, so because I wanted to keep this in an Irish context, I wanted to use the generic construction materials data from the Irish Green Building Council. However, because there was 15 materials listed on this, and 28 in total, but some materials weren't there, so I also adopted the inventory of carbon and energy, and the BIM tools are Revit and Dynamo. So the first script that I used was just to set up a screen template that would encapsulate all of the materials. That's in this database here. So essentially, just creating a starting point for people that are modelling, and within this, each of the materials have specific shared parameters that are associated with them that aligns to its material density, its GWP for product stage, construction stage, use stage, and end of life. What's missing here is the E stage, which is beyond, because this wasn't in the scope of the research. Also, including GWP schedule, that's just a filter in yes or no, just to organise the schedule in Revit, and also a unique identifier. Not applicable for these ones because these are generic, but when I get into real EPD for real products, you'll see where this comes in use. So in Revit itself, created a schedule that would be used for calculation of all the material. So it's a material takeoff with some of the parameters here. So there's the name, the unique identifier, the volume, the density, the weight of the material, the global warm potential for product, construction, use, end of life, and then a combination of all stages. There's total material, GWP in tons, and also kilos, the building gross area, and then the total footprint of the building. So anywhere in bold is just where I use formula to calculate. So that was looking at one aspect was generic materials, but when you kind of get into real products, and when you're moving beyond early design stage, kind of looking at how I could take EPDs that are on for a real product and map them to an element in the model. So I looked at EPD Ireland, and one of the things that I tried to achieve here was taking an XML file, which is an extensible markup language. So as you can see, it's sort of similar to HTML. It just contains a whole list of code that can't be edited from the manufacturer. So, what's on stored on EPD Ireland. So there's a database of PDFs and XML. So with PDFs, one of the things that I wanted to kind of avoid was downloading it, having to flick through it. It's been quite tedious, and there's also room for manual error if someone's inputting the wrong data. As well as this, some of the units in an EPD PDF, for example, for A1 stage, is 1.42 plus E01. So that's not something you can really key into Revit and calculate it. So, but what I found from the XML was that the same value for the same product was 14.2, which suited a Revit workflow. So the idea would be to take an EPD XML from a website, download it, and then map it, just drag it across to this here, which is where I use Dynamo to create a list, and then extract all the global warm potential data from that XML. And then, as you can see, this one actually in here, there's the UUID is actually filled out because that just creates a link between the actual data set and the product in Revit, the material in Revit, sorry. Now, one thing unfortunate for this workflow was that the density wasn't found in the XML file, so that was one element that I actually had to manually input. So it just proved that it wasn't fully automated. So that's for APDs, and then as a visualization tool, whether it's generic or EPD data, the next script was used to kind of how you could present the information visually for people that are modelling away in Revit. So this script, what it essentially aims to do is collect all the values in the schedule that was in the previous slide, take the highest element, and then it'll give you a notification of what the element is. It also highlights it, it also overrides the element with any element that material is associated with in the current view. It'll highlight it red and it'll isolate it, and then also give you a pie chart of all the materials in the model, and just show you the percentages. And for any of the scripts that I've been working on, the output would be to use Dynamo Player, because it just, as a user interface, is just to click the button in most cases, and it's just to kind of allow users to use the workflow that actually might not have the strongest of skills in Dynamo. So that's one aspect of visualization, and then using the model to visualize, and then as a declaration and comparisons, kind of just bring this back to the second theory. So it's using the model as a verification tool, and also as a targets comparison. So a similar script, different output. In this case, it's a bar chart, and you can see the two targets there. They're just the targets that from the REI climate challenge, and then it gives you what your total is, so you can compare and track it across the project stages. Now they could be customly changed if you want. So I just picked in two, just for an example. But as you can see, because this was only modelled on a small portion of a building, the result is like extremely low in comparison. But it's just to show how it could be used to compare GWP targets. And then as a declaration for verification, the results from this script from the schedule and from the script gets mapped to a series of shared parameters that are in the project information. So the total building, GWP building, when it was declared on and by whom, and just be a way of tracking when these values were created across the project, and just to make sure it's within targets. And as a verification tool, you can always kind of reference back to see where it is. And if needed, if you're exporting this to IFC, it'll also come along as well with that. So I'll have a quick walkthrough here, just showing an example of what it could be used for. So the schedule has been set up on the right, just flicking through some of the materials that have been modelled. And then Dynamo Player. So this just gives you the total. So in this case, I modelled CLT with carbon storage, without carbon storage, versus with carbon storage as design options. So just flicking through the schedule, showing the two different ones with carbon storage, and you can see it's a massive decrease on the total. And when you run the script again, you get a different element and different material with the highest value. And you can see the pie charts, and those pie charts can be published to drafting views as well, so they don't always have to reset. And then finally, the last, the carbon threshold. So this will just show you. So I just have the 2025 and 2030 REI targets, thresholds, and then what the value is for this project, and then it's just shown in the project information where it's inserted. Yeah, so just from overall findings from the research, so a template material library that was created so this provides a starting point for early stage GWP assessment, proof of concept workflow with scheduled and visual aids, offering a real-time LTA, real-time lifecycle GWP calculation that may influence decision making. Design options can be used to compare different materials and environmental impacts. By declaring GWP totals, the model may be used as a verification tool to record and track targets at project stages. There is a potential for automated material mapping through EPD datasets and XML files through Rev and Dynamo. However, as I said, the density materials wasn't included, and I had to get this from technical specification. So unfortunately, it proved one element of it wasn't automated as hoped. But hopefully, kind of looking at future work to investigate the impacts of ISO 22057, which is using structured EPD data templates. So this may improve the process of automated material mapping. And also, there's really interesting studies in Estonia in particular of how IFC models can be used for calculating GWP. So there's a whole area where hopefully you wouldn't even need Revit to calculate it. But I suppose on a final note, with this workflow, I was introduced to provide a free alternative solution for calculating and visualizing GWP totals for our users without experience in LCA and EPD terminology, because I know even from my own experience going into the LCA tools without proper training. It can be quite daunting sometimes with a lot of technical terms. So the idea was just to create a free alternative solution within Revit itself for people that are already kind of comfortable with the tools that they already have. And it's never envisioned that it could replace any industry tools for LCA calculations, which are obviously more advanced in what they do and in official reporting. So that's me. Thanks.
Thank you.